Hi, stats class. This week we're going to be talking about regression. If you look at the example in front of you, it talks about points scored in 10 games. Points scored in 10 games. So as we look at that, you see minutes played 28, 35, 8, 20, so on and so forth. When they played 39 minutes, they scored 31 points. When they played only 8 minutes, they scored only 2 points. And the question I have for you is there a relationship between the number of points played and the points scored in a game? And I would argue that, yes, I believe that there is a relationship. What do you think the relationship is? I think most of us would agree that as the number of minutes increases, the number of points scored increases. That's what we would expect the relationship to be. Now, it doesn't mean that that's always the case, and that's why we have a mathematical study behind it. It is called regression. The study of the relationship between two variables or more variables. In this case, we're only going to do a 2 in this class. But the study of the relationship between variables is called regression. It measures for us the strength of the relationship between the two variables. It could say, hey, we have a really, really strong relationship. As one increases, the other increases. It could say we have a very, very strong relationship that as one increases, the other actually decreases. You could have also a situation where it says there's kind of a relationship, but it's rather weak. You could have other situations where they say these variables really aren't related at all. If you suggest that they're related, you're really kind of making it up. The measure of the strength of the relationship is the correlation coefficient. We call that the R value. Look over here on your right-hand side. This first plot would be a plot of data. We use scatter plots to be able to determine relationship between data. You can see that as one increases, the other increases. So it has a positive slope. As one goes up, the other one goes up. We would say that that's a positive correlation, as a positive slope. On the next one, we would say that the data trends downward. So as one increases, the other decreases. That's a negative correlation. It would have negative slope if you were to draw a line through that. And finally, this third one here, you can see that it's scattered all around. It would be really tough to say, is it trending up? Is it trending down? There really doesn't appear to be much of a trend at all. And so in that situation, we would say there is no correlation. Correlation R values, if you look at the screen right below you, it says R is a value within the range of -1 to +1. So it's always got to be between -1 and +1. 1 and -1 means super strong relationships. 0 means no relationship. So the further we move towards the end of 1 or -1, that means strong relationships. Positive just means it goes up. Negative, it means it goes down. So if you look at this one, this first example, where you have these data points that are trending down and they're all kind of tightly knitted together, that's a strong relationship. So it's going to be close to -1. In fact, -0.95. And the next one, it's definitely trending down, but they're kind of pulled apart a little bit. So it's not as close to -1. It's a -0.6. And the next one, you can see the data points are scattered on both sides. They're far apart from each other. There's really nothing that is telling us, does it go down or does it go up? So therefore, our R value is 0. My dog, if you hear her, she's right beside me right now. And then the next one, we say that the data looks like it's trending up. Definitely looks like it's trending up. I just realized that depending on which arm I use, that probably doesn't work too well. I got to use left to right. Definitely trending upward for this one. And so it's positive. Not real close together, but positive. And then the last one, data points are really tightly packed together, and it's trending upward, so 0.95. Notice that it doesn't actually tell us the slope, just tells us whether the slope is positive or negative, okay? Just tells us whether the slope is positive or negative. So let's answer this question about points scored. If you click on in class 1 and jump on over here, it says produce a scatter plot of this data. We're going to determine the strength of the relationship. So I go minutes, and I'm going to go points. And under minutes, I have to put the data in order: 35, 8, 20, 39, 23, 19, 27, 15, and 30. For your assignment, you need to do the 2 in class. So the idea is that you do the 2 in class together with me to make sure you're getting the right answers. So I want to see all 4 of these tabs completed for your homework assignment. So if you need to pause this video and go open your homework right now and start working through this with me, go right ahead. That's the idea, that we do it together so that you're able to then do it on your own. So I want to see that all 4 of these get done. Points are going to correspond those the same. So 28 is paired with 16. So I press 16. 35 is paired with 13, and so on and so forth. 10, 9, 15, 4, and 19. Easy to make a typing mistake. So if you end up with a result different than mine, go ahead and check, or maybe you'll check and see if mine wasn't typed right. Okay, so I'm going to drag this over here as I produce my scatter plot. As you produce a scatter plot, click the data. If you select the minutes and the points, it will put that on the graph as well. And we're going to insert a chart. And Google Sheets does a great job of selecting a scatter plot. That's what we wanted. Selected the scatter plot for us. I'm going to try to grab somewhere on the graph. I can drag it on over here. Excellent. Now that we have that, there's some things that we want to edit with it. First of all, if it didn't grab a scatter plot, you select in the setup, you go down to scatter plot right here. But we do have a scatter plot. We'd like to customize it. The only way you really want to customize this is by going into series. And as you select series, we would like to do this. We would like to add a trend line. Notice how the line got drawn. It looks like it is trending upwards as we thought. And then there's 2 more things you need to do. For label, use your equation as a label, and it puts the best fit equation for the line right there. And then finally, we also want to show R squared. That's all the information we're going to need. And so I'm going to click out of that, and I'm going to put my chart right on over here. Okay, that's a great chart for my data. I'll move my screen over here as well. Now I can answer these questions. Produce a scatter plot. We did that. Describe the relationship of the data. As the number of minutes increases, the number of points increases. Strong positive relationship. If you look at your data points, they make a nice line. So I would expect this to be a strong positive relationship. Determine the correlation coefficient. Well, look, it gives us R squared is 0.783. If it gives us R squared, we have to compute R, so we have to take the square root of that. So I like to use decimal scientific calculator, and I'm going to choose square root of 0.783. And you can see it produces over here 0.885. We're just going to go 2 places, so 0.88. R equals 0.88. That confirms a strong positive relationship. Determine the equation for the best fit line. Look at this line produced right here. It says points equals 0.775 times x plus negative 0.58. Here's how I'm going to write that. P for points is equal to 0.775 times, I'll use parentheses. And what is x? X in this situation is our minutes. So I use M for minutes. And then plus negative 0.58, I'll write minus 5.8. Sorry if I said 0.58 there. Okay, now that we have that equation, we can answer some really good questions. It says, using your best fit line, how many points would you expect someone to score if they played for 48 minutes? I'm going to use this screen, dry erase board right behind me, and we're going to show how you can figure that out. I go ahead and I'm going to use my equation for my best fit line, which again, P equals 0.775 times M minus 5.8. And the question is, using your best fit line, how many points would you expect someone to score if they played 48 minutes? So we're going to go ahead and put 48 right in there. And we get P is equal to 0.775 times 48 minus 5.8. Well, let's go ahead and put that right in there. I'm going to go to my Desmo scientific calculator, and I'm going to back out of that, and I'm going to write 0.775 times 48, and then I'm going to minus 5.8. And you can see it produces 31.4 for me, 31.4. So I would expect 31.4 points to be scored if they played for 48 minutes. And finally, the last question says, using your best fit line, how many minutes would you expect someone to play if they scored 10 points? So I'm going to go back up here, and I'm going to change it so that the points is 10. I'm going to put 10 in for here. When I do, I get 10 is equal to 0.775 times m minus 5.8. I add the 5.8 over and I get 15.8 is equal to 0.775 times m. Divide both sides by 0.775. I'm going to need my calculator for that. 15.8 divided by 0.775, and I get 20.39. So 20.39 minutes. And there's a really good example of linear regression from the outset. We produced a scatter plot. We produced R values. We were able to answer some very good questions. We're going to stop the video there, and we're going to do another example, the in-class 2. Again, make sure you do these together, and then you can do the 2 on your own.